What up, everybody? Today we've got one from the Lund gang. Someone posted this up, melting their brain. Let's see if we can help them out. What have we got today? We've got a volume of revolution. As always, a big chunky question. Let's flash it up on the screen here. Take a second, pause it, have a read. Excellent. All right, roughly what have we got? We've got this curve C that is defined parametrically by x is 3 tan theta, y is 4 cos squared between 0 and pi over 2. We've got a couple of jobs. We've got this line here which is normal to the curve at P, and P is at the point 2, 3, if memory serves, 3, 2 even. Let's try and not make a mistake writing the question down. First job is to find the coordinate of Q. This will define the area S, and we are then going to find a volume of revolution as we rotate that around. But one thing at a time, minions. Let's do part A. I reckon we can do A here, B up here. All right. We've got parametric equations. We've got a point P. We need to do something at point P. The first thing we need to do is find what the parameter is. You could choose the X, you can choose the Y. Looking at that, X looks like more of a good time. So if X is 3, which would be 3 tan theta in terms of theta, what should theta be? That gives me theta. So 1 is tan theta, therefore theta should be pi over 4. Now we do need to be careful because of course I could keep adding pi to this, 5 pi over 4 and so on and so forth. However, my curve stops at pi over 2, so I should be okay. Being the slightly paranoid person that I am, I'm just going to do a quick check, make sure I haven't mucked up here somewhere. So let's put theta back into y. So that is cos squared of pi over 4. Pop that into your calculator if you want, but you know that cos of pi over 4 is root 2 over 2, or 1 over root 2. Square that, you get a half, times 4, you get 2, which is what I want. So theta is in fact pi over 4. I want the equation of the normal, so I am going to need dy by dx, which is dy by d theta over dx by d theta. Cheeky chain rule in there. Let's see, we can differentiate that. Dy d theta. So we've got a chain rule again. So cos squared becomes 2 cos theta. Differentiate the cos. We get a minus sine theta. We will get a minus 8 cos theta sine theta. And dx d theta, oh, nice simple tan, that will be a 3 sec squared theta. I'm not going to muck about with that too much. Let's put in theta is pi over 4. And what do we get? That will become a half, so we'll get minus 4. Sec squared will be 2, so minus 8 over 6, minus 4. 6 minus 2 over 3. Unless I'm very, very much mistaken. No, that's okay. Right, so that is the gradient of the curve at that point. I now need the equation of the normal. Let's go y minus y1. Now, if it's minus 2/3 for the tangent, the normal has a gradient of 3 over 2. We then need to find where it crosses the x-axis. We put in y0. I get minus 2. Minus 4, minus 4/3 plus 3. I get x is 5 over 3. So this point here is at, point Q is at x is 5 over 3. There we go. Again, a couple of steps of algebra you might want to pop in for yourself here. I'm a little bit cramped. As it is, we're all skewy. I'm at the bottom of the board. Please forgive me. Okay, step 1 done. Step 2, remind us, we're going to take area S and we are going to do a volume of revolution by revolving it around the x-axis, spinning it around, and we'll get this 3D shape. And our job is to find its volume in terms of pi's. All right. Now, looking at this, much like with anything, the plan is we are going to pretend that this bit isn't cut off and we'll remove it afterwards. And the hint for that is in the question. If you go back and look at it, it does tell you that you can use the volume of a cone. what shape do I get if I do a volume of revolution of this triangle? You will get a cone. So that tells me that that is the plan. So a volume of revolution is what? The volume is pi integral of y squared dx. We are working parametrically, so we're going to have to do this in terms of thetas. Nice cheeky way to do that. Let's divide by d theta and multiply by d theta. Technically, change a variable probably in there if you want to be completely accurate, but I like to think of it this way. So what does that tell me? What does that give me? I get a pi. Well, that's good. That's always nice. What values of theta? So down here, that will be theta is 0. Probably should check that actually. 3 tan 0 is 0. 4 cos squared of 0 is 4. Yeah, that looks about right. We're going up to point P, and this is where that was super useful to get as well, which is pi over 4. Y squared is 16 cos to the power 4 theta. Dx d theta is 3 sec squared theta d theta. Now at this point you might be panicking and you might have a nosebleed. Understandable. Understandable really. Further mathematicians, let's not get carried away. If you've been watching some of my TikTok, you know I have a bit of a thing for demoivre, but we're not going to need that because what we can see is actually there's some cancellation here. So let's take the 3 and the 16 out.
May I have your attention, please? The fire alarm system is about to be tested.
Okay. 48 pi, 0 to pi over 4. Now, cos to the power 4 theta and sec squared. Remember, sec squared is 1 over cos squared. So that is cos squared theta d theta. Okay. Now, we can use... Okay, sorry about that. I think we got interrupted there by the fire alarm. So, coming back to this, cos to the power 4 theta and sec squared, by writing sec squared as 1 over cos squared, will cancel to give me a cos squared. Now at this point we are in very familiar territory. We are able to use the fact that cos squared is in fact cos 2 theta plus 1 over 2, and then we've still got our d theta. So where does that leave us? That will give, I'm just going to pull the over 2 out. I don't want to carry that with me. Cos 2 theta integrates to sine 2 theta over 2. The 1 there will integrate to the theta. Remember, I've taken that 1/2 and pulled it out front. That's 0 to pi over 4. So let's plug that in. That's 24 pi times sine of 2 pi over 4, which is sine of pi over 2, which is 1. So that will give me a 1/2. And then I get another pi over 4 from that. Let's take away the 0. Sine of 0 is 0, 0 of 0, 0, 0, 0, and 0. So that will give me this answer. And if we expand that out, I will get 12 pi plus 6 pi squared. And that's good. That feels good. That feels nice. However, we're not done yet. So what we've done here is we've just taken the entire curve up to P and spun it around. But obviously we don't want this section, so we're going to have to figure that one out. Now, if you hate yourself and you don't have anything better to do, you could do this as a volume of revolution. You could find the equation of that line and do all of that. But the question helped us out here, and they said, hey, yo, what about, why didn't you just think of it as a cone? And we're going to spin the cone around, right? We end up with a cone looking something like this. That probably didn't help, but I tried. Now, what's the height of the cone? Well, we said that. That just absolutely did not help, did it? Right. Classic. It's what happens when I try and be artsy. Right, so P is at x is 3, Q is at 5/3. So the height of the cone is going to be that distance there. So if we have a look at our cone, the height is 3 minus 5/3, which is going to be 4/3. The radius of my cone is going to be that distance from there to there, which is just 2. So the volume of the cone is 1/3 pi r squared h, which is 16 pi over 9. which gives a total volume of the entire shape that I want of 6 pi squared plus 12 pi minus 16 pi over 9, which is 6 pi squared plus 12 pi is 108 pi over 9, 98, 92 pi over 9, 92 pi over 9. Et voila! Cheeky bit of volume of revolution for the Lon gang out there. If you have any more questions, do keep posting them. We are checking the Lon gang Reddit, and we will try and get them answered up here whenever we can. In the meantime, subscribe, like, click the bell, all that good stuff, so that you can keep on track and keep nerding out on all this glorious further maths content. I'm Nick, I hope you enjoyed it, and I'll catch you next time.